Okay, so now we're on question B. We've still got these letters algebraic, and there must be no more than 2 letters between the 2 A's. Okay, let's look at this in 2 methods. Probably some more, but let's start by saying, well, let's place all the other ones, right? So take these 2 A's out, and we're left with 7 letters. So there's 7 factorial, or 7p7 ways of arranging those. Now, what we've got, so that's the 1, 2, 3, 4, 5, 6, 7, right? Now we need to put our A's in, and there are 3 scenarios we need to think about. We could have AA together, in which case they could go over there and all the other letters, or here, 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 here. Let me just check my counting. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so we've got our 7 factorial, and then we're going to multiply that by these 8 different ways that we can place the AA. Or we've got our 7 factorial ways, and we can multiply that by 1, 2, 3, 4, 5, 6, 7 letters left, right to place. And we could put an A and have a gap between it, right? Well, there's one option of doing that. And you could move it along and have A and A over there, so a second option. Or you could have a third option, which would have the A and the A over here. So you can just count like this to go, well, the one option was A and A, that's 1, 2, 3, 4, 5, 6, 7 ways. So now you can take that, maybe I should do this and say that was 8 ways, this was 7 ways. So in other words, the top option is 7 factorial times 8, this one 7 factorial times 7. And our last option for the A's is that we've got 1, 2, 3, 4, 5, 6, 7. Those are the 7 non-A's that are placed. And we could have an A, a gap of 2, and an A. So there's one option. And this could move across. So we've got A and A. So there's a second option, third, fourth, fifth, sixth option. So there's 6 options, ways of placing the A's with a gap of 2. In other words, we've got 7 factorial times 6. Now, you could, of course, just have combined that and thought, well, place all the other letters, and then there are 8 ways to have AA, plus 7 ways to have A gap A, and 6 ways to have A gap gap A. Okay, and you get whatever, 105,840 when you multiply that together. Okay, but let's look at another option, and you'll see there will be a slight overlap in the option now. Well, I don't know, there's some thinking that's kind of similar, and that is, don't place everything just yet. Let's look at those 3 scenarios. You could have AA, and then 1, 2, 3, 4, 5, 6, 7. In other words, you've got that AA must be together. Now you've got 1, 2, 3, 4, 5, 6, 7, 8 objects. You think about this, I think we did an example with the library books once before. You kind of put a rubber band or made it into a box set. So there are 8 objects here to arrange. Well, that's just 8p8 or 8 factorial. Okay, or we could have another thing A, and then we left with, well, 1, 2, 3. So wait, where are we here? 1. So let's do the A gap A. Let me leave a little gap here. Undo. And we got 1, 2, 3, 4, 5, 6. Right? So this we're saying needs to go together. We're putting a little band around it there. So we need to choose what letter's going to be over here. Well, there's 7 that are there altogether, 7 non-A's. And we're going to choose one. Now I've said 7p1, and of course 7c1 would have done the same thing. We're choosing one to put in there, and there's only one order. So 7p1, 7c1, of course, are the same. And we need to arrange these 1, 2, 3, 4, 5, 6, 7 objects. So we've got 7p1 times 7 ways of arranging these 7 objects, where one of the objects is another letter A. And the last option we could have is, let's go blue here. So we've got A gap gap A. And then we're left with, that's 4, so we should be left with 5 letters. 1, 2, 3, 4, 5. And what we're saying is that one of our objects must be A, another letter A, right? Because the A's must have at most 2 between them. And so here we must choose these 2 over here. And now out of the 7 non-A's, we want to choose 2, but the order matters, right? Because if it's LG or GL, that's going to be different. And now we've got 1, 2, 3, 4, 5, 6 different objects. So having chosen this, we now want to arrange our 6 objects where one of the objects is A, non-A, non-A, A. Okay, there's quite a lot going on here, but this is the fun, isn't it? Oh, these are lovely. So we can do that. Now, just as a quick aside, as if there wasn't enough going on enough already, of course, for that 7p2, we could have just chosen the 2 and then arranged within it. But why? Why would we want to break that up when you can just go 7p2? Okay, so you could take all of these and add them together, and you'll get the same glorious 105,840. And yeah, there were 2 nice ways to do it. A third way out of interest, I guess, would be to take all the ways of arranging it and subtract the things we don't want. I don't really like that idea because it feels like there are more things that we don't want than things we want. So this is quicker. There are only 3 options we had to consider. So yeah, anyway, hopefully helpful to think through those. There's a lot going on, as I said, but that's the fun.